talk about regression. So regression is a super cool word that makes you sound really smart. It basically means line of best fit. So, but you get to use fancy vocab. So when I say regression line, I'm really just talking about the line of best fit. Um, Back in the day, I think it was ninth grade science, they would tell you to put as many dots, try to get the same amount of dots above the line as below the line. Does that make sense? Like when you're trying to like wiggle your ruler around to try to get the line of best fit. What did they tell you in middle school? Same thing? I can't remember. But in this unit, we actually figure out how to find the real line of best fit, and it has some very specific criteria. So we're going to say regression line is the line of best fit. Regression is a word that is used in the wild. It's not like a contrived college board word. That is a industry word. So when my ex-husband was doing his marketing graphs, he would come over and be like, "Can you check my regression?" Again, made us sound both very smart and educated, but really it was just Excel. But anyway, so this is a model that shows how the response variable. Okay, and which one is the response variable? I'm asking, is it X or Y? Y. Changes as the explanatory variable. Which one is that? X. And how can you remember? Because it's got an X in it. Explanatory, yeah. Changes. And remember that just because you can make a line and the dots line up doesn't mean that there's causation there, just means that they're correlated. Now let's talk about the format of the line of best fit. And I sort of spoiled this for you a little bit last Friday when I showed you our syllabus graph. This is what it looks like. And let's talk about the symbol, this new symbol. This guy is called Y hat. Like literally, it's called Y hat. I've had students dress up as Y hat for Halloween. I don't even know if they're very special. But yeah, Y hat is his name. And I don't know why they call it Y hat, but the hat means predicted. So you say predicted Y. And so the hat is like the same thing as putting the squiggle next to a decimal, like approximately. I like to think of the hat, and I know I realize I'm recording, but it's covering your ass. So it's an estimate. You're saying predicted Y, not for sure why, but just based off this mathematical model, we're covering ourselves with this hat, saying it's just a prediction. So predicted Y equals A plus BX. A is the y-intercept and B is the slope. So I want you to think of it like mx plus b. It's just that the b is in the front, which makes more sense because what do you grab first? B. Anyway. Right. Okay, so it's no big deal. A is the y-intercept, B is the slope, and Y is Y predicted, but his name is Y hat. Okay, now we're going to shift ourselves over to our graph, which I have definitely located right here. See, but you won't forget it now because I did a swear. Always works every time. Okay. So if you could, please and thank you. Write those things down on your graph.
I would never. This is your hand length and your starburst amount. Wow. Okay.
Again, AP students, if you could please follow directions and write these things down on the graph side of this paper, not the table. Don't worry about the table. We're gonna use the table, but that's just your number of starburst.
Okay. So your next question is, we need to graph the line of best fit on here. But I told you in the first lesson of chapter 3, you don't have to start your graphs at 0. And I did not. On the X, actually, my graph starts at 11. And so what you want to do is you want to plug in a number on the left side of your graph paper and plug in a number on the right side of your graph paper, and then draw the line between them. Okay, so the left side of my graph paper is 11. Make yourself a little, like you're taking notes, basically. Do you guys understand what I'm doing here? Could anyone intelligently explain what I'm doing? Yeah, I'm plugging in the something on the left side of the graph so that I can find a point to put for my line. So the very left side of my graph paper is 11. So I plugged in 11 and I got 12.8. That means I can graph the point 11, 12.8. That's going to be the left side of my line. Does it make, are you getting it? Okay, what's the right side of my graph paper? 23. Just because I wanted to differentiate it, I made the dots for these two coordinates kind of obnoxiously big. How does that line look to you guys? It looks like reasonable. I think it's pretty good. You know, you just never know how stuff's going to come out when it's real. So I'm pretty happy with it. Anybody need more time with the pink sheet? Okay, now slide the pink sheet back off to the side and grab your notebook again. Okay. Predict how many starbursts a person can pick up if their hand length is 15.5. So right here, we're gonna write y hat equals negative 4.8 plus 1.6x. I'm just copying this over from my pink sheet. And you might be, if you're a engaged student, wondering how I got this, and I will show you that later, not today. Okay, now, next thing I need to ask you, 15.5 centimeters, is that an X or a Y? Look at your graph, look at the labels. Yep, X. So we just plug it in. Y hat equals negative 4.8 plus 1.6 times 15.5. Oh, came out nice. Okay, then what we're gonna do, just because we're really studious people, we are going to just check our line. We're gonna go over to 15.5 in our minds and see if that answer of 20 makes sense. I like to be able to check my answers before I walk away. Okay, next one. Predict the hand length of a person who picked up 28 starbursts. Is 28 an X or a Y? Y. Okay, so add 4.8 to both sides. Divide by 1.6. Okay, then let's check our answer on the graph. 20.5. 28. Yeah, it's actually almost perfect. Any questions about that? So you're going to have an equation. You have to decide if they're given an X or a Y. You plug that in and solve for the other one. Okay, set up the rest of this, please. Oh, no. I got a case of the Mondays. This is what the homework was like. Okay, so on your own, decide if 10 is X or Y, plug it into the equation, and get the answer. So on your own, decide if 10 is X or Y, plug it in. You can talk to each other, it's fine. Extrapolation. That's not what we're doing though. You're just deciding if 10 is X or Y and plugging it in.
Is it always making it first when you just plug in?
That's for our Starburst thing.
Oh. I thought that was like the formula, yeah.
Just
So
for the
we
Starburst
still
thing.
use that though?
Yeah.
Okay.
Everything today is about hands and Starburst. So but each scatter plot has its own line. And I'm going to teach you how to find the line part on the block day. All right, here's what I got. Maybe. I got 11.2 starbursts. Okay, now that's all well and good, but notice there's a second question here. And it says, how confident should we be with this prediction? So take a look at your axes on your graph. And what's the lowest data that we actually have? Not 11, that was predicted on the line. Yeah, what was our lowest actual data? 13. 10 is pretty far away. Okay, so think about like the hand size of somebody with a 10, it'd be really small. Now it might, we should be less confident because we're farther away. Can you guys please focus? Okay, so if it's far away, we're not going to be confident about it. And notice I specifically said from 13, not from 11. Okay, and doing this is called extrapolation. So this is kind of a no-no, predicting something way outside of your data range. And the vocab word for that is extrapolation. Okay, so extrapolation is the use of a regression line equation to make predictions outside of the X values of our data. And people do it all the time. It's like, what else would you use the mathematical model for if you had data all around it? It happens. It's just not great. It's not a great technique to do. But what makes sense is the farther away, the less confident. So the farther away you get from your actual real data, the less confident that you're going to be in your answer. Can you sort of make a prediction? Yeah. And you should just say, you know, only for the X, only for the X. The farther away that you go on either side, the less that you can really, the less that you can really say. But you could just say it in your report. Like if you were doing a report, you could be like, you know, I understand that this is probably extrapolation, but I could make a prediction of blah, 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 blah. Okay, now residuals. This part's going to be great because we get to mess with Evan's data. So you picked up a lot of Starburst, man. Okay, so residuals. Has anyone heard of residuals before? Yeah, okay. So residuals are represented by vertical lines from the scatter plot points to the regression line. Residuals are represented by vertical lines from the scatter plot points to the regression line. And there is a formula that's very important. Residual equals y minus y hat. Put a little box around this, and then we're going to say what this is in words, because the symbols will trip you up at first. They won't forever, but at first they will. So this is what that means. Actual y minus predicted y. Okay, so now we're going to, after you write this, take a second. We're going to practice this interpretation. Don't worry, we're going to use Evan. Because his is just so far off the line. So if you could actually take your pink graph, look at the back, find Evan Reed's point, and then locate Evan's point on the graph. I'm going to take a different colored pen and put a little circle around Evan's point. So if you can locate that one. Reed, R-E-E-D.
Yeah.
What's wrong?
Oh, yeah. Put your Damn.
Yeah. Did you guys find it? You can. I'm going to. Oh, you're so cute. No, I meant the circle around the actual coordinate. Oh, because you use Slurp pen. Okay, I have to be honest with you, completely 100% honest. I wrote all of this stuff on there in Flare pen the other day, and then I was like, I had to throw it away. Bad choice, bad choice. Okay. So, guys, first we're gonna draw in the residual, and we're not gonna draw the residual in for every point, for obvious reasons. It would just make this graph look ridiculous. But I tried to pick the one that I thought would have the biggest residual. Funny enough, I think I have the biggest residual in fifth period, so you're gonna have to use mine in fifth period. But I just picked the one that looked like it was the farthest off because I really wanted you to be able to see it. Like it's a visual exercise. So we're basically what a residual is the amount of error that the prediction line would give you. In Evan's case, the prediction line is extremely underestimating what he was able to pick up because the line is way under the point for him. Okay, so we're going to flip the notebook. So leave that. Yeah. This is the rest. Okay. So we already drew it. Drawing is done. Calculate. We're going to calculate it on here. We're actually going to write the interpretation sentence on the pink page though, because I want you to be able to use this paper as a reference. So we're going to calculate it here. So as a reminder, the formula is residual equals actual minus predicted. Okay, so what was Evan's actual Y? His actual number of starbursts? 40. Okay, now put parentheses because the predicted, we're going to put the equation in there with his X. So Y hat is, if we look right here, negative 4.8 plus 1.6x. So negative 4.8 plus 1.6. And what was Evan's X? 19.5? So what this is saying is that Evan picked up 13.6 more starbursts than the line would have predicted for him. That's almost as many starbursts as I picked up myself. Yeah. Okay. So go back to your graph once you get that. Ignore this for a second. Okay. So this is how the sentence starts, the difference between the actual. Okay, what's the first blank? I'm right here. The difference between the actual Y unit is number of starbursts, great. Do you guys see where I got all those things from? Okay. We have 11 minutes and 3 more things to do. So we're gonna have to ramp up the speed, even though I don't feel like ramping up the speed, but that's fine. Okay, that's the end of this. And if we don't do this part on the pink page today, we can start with that tomorrow.
So if you're speeding and finish writing, the last thing we're gonna do is solve for y in the top one. And then in the bottom two, we're gonna go to the paint page and write those two sentences for our y-intercept and r squared. Which you probably start to do yourself. Not hard, it's just kind of lengthy. Okay, so let's just see if we can start this. Residual equals y minus y hat. That sounds like a formula-worthy note card. No, note card-worthy formula. What is the residual in this problem? -11. And actual is what I'm solving for. So I'm going to leave the y minus, okay, and y hat is our equation. -4.8 plus 1.6. And what's x in this problem? 20.5. Add 28 to both sides. Who is it? It's me. So if you guys check the table, I have, where am I? Oh yeah. 20.5, 17. Oh man. Okay, last thing. Y-intercept and slope. Very quickly, these are very easy. So at 0x, we predict a y. Okay. At 0 centimeters of hand length, we predict -4.8 starbursts. Now that doesn't make sense. Like logically, it doesn't make sense. A lot of the y-intercept things don't make sense. That's why we don't start our graphs at 0. That doesn't mean the sentence is wrong. It just means that in context, it doesn't make sense. Like in real life, it doesn't make sense to have -4.8 starburst when you have no hand, but whatever. Okay. For every increase in 1 centimeter of hand length, we predict. And okay, and then we have to pause. This is our first decision. Increase or decrease? Increase. Then you can tell from the sign of the slope, you can tell from the graph going uphill.
I did it. Oh, nope, I lied. It's tomorrow. It's tomorrow. Okay, so tomorrow, just so you know, I'm going to teach you how to find this on your calculator. So you need your calculator tomorrow for sure, so that we can figure out anything other than hand length and starburst.